This video is going to go over a few formulas where we're solving for a variable, but there's also variables in the formula. So the first thing, anytime I'm looking at a formula, when I see the variable that I'm supposed to solve for in the denominator, I know it has to come out of the denominator. So what I'm going to do here is I'm going to multiply by the LCD. I can put the 1 over 1, and I can see the LCD here is going to be k. So I'm going to multiply each one by k, or k over 1. Now I can do this when I'm multiplying in an equation. I can multiply each by the same number and it keeps that equation balanced. Okay, so these two cancel and I'm left with just e. Here I'm left with minus 1k, or just minus k, equals, these k's will cancel, and I'm left with just 2m. So I need to solve for k, so I subtract e from both sides. I get negative k equals 2m minus e. Now I need to have positive k, so I'm going to just divide by negative 1 to each term. And I end up with k equals a negative 2m plus e. And that would be our final answer on that one. Okay, our next equation is y equals 10 over 7 minus x, and we need to solve for x. So notice again here we have x in the denominator, and so we need to get x out of the denominator. Anytime we're solving for that variable, it can't be solved for if it's in the denominator. So I'm going to do that same thing. I'm going to multiply both sides by 7 minus x over 1. So I'll do that on both sides. And again, I can do this as long as I multiply each term in the equation, because it keeps that equation balanced. So 7 minus x will cancel there, and I'm left with y times 7 minus x equals 10. Okay, let's go ahead and distribute this y in. So we'll get 7y minus xy, or yx, it doesn't really matter which. Typically you'd write xy, but equals 10. Now remember, we're solving for x, and so we want to isolate the x on one side. So we subtract 7y from both sides. Those cancel. I'm going to bring this up here. I end up with negative yx equals 10 minus 7y. Now, just like if I had 2x equals 10 minus 7y, we want to get rid of this number in front, and so I just have to divide by whatever number is in front of x. So in this case it would be 2, but in the problem that we're doing it would just be a negative y. So divide this side by negative y. So those cancel. I end up with x equals, we can leave it as 10 minus 7y over negative y. We could also write it separately, each one 10 over the negative y minus 7y over negative y. So 10 over negative y minus 7y over negative y, which we could simplify to negative 10 over y, and then plus, those two would cancel, so negative divided by negative is positive, so it would just be 10 over 7. Oh, oops, this y got cut off, but that is a y. And so either of these answers I would accept on the exam, but it's just good to make sure you know how to get to both of those. Okay, our next equation, we need to solve the equation for y. So we have 8 over h equals 7 over y plus 7 over m. So notice in this one, we're going to have different denominators, not the same as we did in the last couple of problems. And so what I would do is first, let's find our LCD. Well, in this case, it's got to be h times y times m. So just HYM. So what we can do is just multiply each by what it doesn't have. So HY times HY, here we can do MH and MH. So we're really multiplying by 1. Remember, any number, so HY over HY, since it's a number over itself, it just equals 1, so it keeps the same value. And then this one will have MY and MY. So we'll end up with 8 MY over MYH equals 7mh, and I'm going to just rewrite that order to myh. Remember, when you're multiplying, the order doesn't matter. And then plus 7hy times myh. Now, because all the denominators are the same, we know we could multiply by that LCD. Those would cancel. So I end up with 8my equals 7. In fact, we're going to need a little more space, aren't we? 7mh plus 7hy. Let's go ahead and put this up here where we have a little space. So 8my equals 7mh plus 7hy. So remember, we're solving for y. So what we did there is we just got rid of the denominators. So if I'm solving for y, I definitely need all of the y's on the same side. Anytime you're solving, you've got to have all of those variables. So we're going to subtract 7hy over. So now I'll have 8my minus 7hy equals 7mh. So I'm solving for y, so I've got to isolate it. And one way that I can do that here is I can factor it out of both. So I factor y, the first term I'll just have 8m, the second term I'll have minus 7h, and then still equal to 7mh. Now, just like if I had y times 2 equals 7mh, well, to get y by itself, I would divide by 2. So similarly, to get y by itself, I'll just divide by that 8m minus 7h on both sides. So those would cancel, so then our final answer would just be y equals 7mh over 8m minus 7h. Now, on the last problem, we only had a monomial, or just one term in the denominator, but here we have a binomial. These have to go together, and so we're not going to be able to rewrite this. So this would actually be our final answer. All right, this will be the last problem. So it's another similar problem where we have an equation made up of mostly variables, and we have to solve for r. So we're going to do similar to what we did in the last problem. We're going to multiply everything by the LCD just so that we can clear all the fractions. Okay, so I can see my LCD has got to be r times r1 times r2. So r times r1 times r2. So I'll multiply this first one by r1, r2, similar to the last one. I'll multiply this one by r2. Okay, so same thing, we have a number over itself, which its value is 1, so we're not changing the value when we do it this way. And then we have r1 here. So first one will have r1, r2 over r1, r2 equals r2 over r1, r2. I feel like I keep thinking r2d2. It's too bad we don't have a d2. It would be perfect. So r1 over r1, r2. Okay, so we've got it all written out. And just to check, we should just have the 2 missing in the denominator or in the numerator. So notice this one was r, we have r1, r2. This one was r1, we have r2, the other 2. This one was r2, here we have r1. So that's correct. These are going to cancel. We can multiply by the LCD. Those will all cancel because the denominators are the same in an equation. So now let's write what we have here. So we have r1, r2 equals r2 plus r1. Now we are solving for r in this case, and we got lucky. All of the r's, just the plain r, is on the same side. So we're going to do kind of the same thing we did before. Remember, we're trying to isolate that r, and so we're going to distribute it out to factor it out. So we have, sorry, not distribute it out, factor it out. So we factor out an r, we get r2 plus r1 is equal to r1, r2. So divide, we get R2 plus R1. Those two cancel, and our final answer we end up with is R equals R1 times R2 divided by R2 plus R1. Similarly to the last problem, because this is a binomial, this has to either to cancel altogether, and so we won't be able to simplify it with the numerator. So that would actually be the final answer.